Hi, everyone. Welcome to another episode of Neo4j Live. My name is Jason, and I am filling in for Alex today. In the chat, definitely let us know where you're coming from. I am joining live today out of San Francisco, and out of Thailand, we have a very special guest, Artemiy Vereshinskiy, with RushDB. Artemiy, yeah, how are you doing? How's everything in Thailand?
Yeah. First off, thank you for having me here. It's really pleasure to speak up about graphs, especially with you. And today we're gonna, I think, discuss my journey with graphs, RushDB especially, and how graph thinking could change broader audiences' minds. I think that's our goal.
Yes. So yeah, do you want to give everyone kind of a quick lowdown on what RushDB is?
Yes, definitely. I think RushDB should be presented from really early days. It, to be honest, began as a solution for collectors. So its real power lies in reshaping how anyone filters and interacts with complex data without traditional engineering overhead. So RushDB didn't started as dev tool. It started as a collector. As a friend father, a serious CD collector, brought a new disk, only realized he had one already on his shelf. He was really upset. That frustration moment, accidentally duplicating an item in a large personal archive, sparked the original idea of RushDB. What if people could catalog anything and explore their data like you would do in Notion, but with first-class filtering, no matter the structure. So that became the first version of RushDB, a B2C platform for collectors: vinyls, coins, cars, anything. Flexible views, powerful faceted search out of the box. But the deeper I got, more I realized that the real problem wasn't in collections itself. It was the data interaction at large scale. So corporations like Meta just try filtering their marketplace. You know what I'm talking about. It's weird. Or even Amazon still struggle with building faceted search experiences that adapts intelligently as filters change. And if you build that kind of thing, adding a new checkbox might lead to huge development backlog, days of backend work, front-end updates, data migrations, syncing with teams, and that's insane, I think. So I was naive those days, thinking that no one solved this because it was easy. But in truth, no one solved it because it's hard. So RushDB pivoted. So from niche tool for collectors into self-aware database with Fractal API that can describe, filter, and reshape any data set instantly. That's the idea of RushDB. Today, we'll dive into how this engine can power not just personal catalogs, but any data-centric product from SaaS marketplaces with no schema stress, no filters, manual boilerplate, and wrestling with data. I think that's pretty sure short history about how RushDB emerged.
Oh, that's amazing. So, are you a collector yourself? Is that how you got involved in this space?
Yes, definitely. And all my family from time to time was involved in collecting some stuff. My father was collecting guitars. My grandma collecting minerals and coins, and me personally collecting different stuff too. I'm really into Lego stuff and really like beer caps because some of them are really fancy. But nomad life isn't for collectors. So I'm still looking for solution that helps me to digitalize my collection to have it always with me but storing it somewhere else. I think one day me and my co-founder will definitely go back to the idea of B2C platform, but this speech not about that.
Well, it sounds like you could, when you
So, yeah.
do that, you can build it on top of RushDB, which would be a super
Yes,
meta and super
yes,
interesting.
definitely.
Cool, awesome. Hi, was it Junaid from UK, Mark from South Africa, and Daria from Moscow. If you guys get a chance, if you're also collectors, if you could post what you collect there, we could. That would be super cool to maybe loop into the show here.
Yep. We will drop some ideas of what we should do with RushDB as next pet project.
Yes, that would be great. Cool. Okay. If you're ready, why don't we show the audience a little bit of RushDB and how to use it, and kind of walk through why people should use it.
I think before we start demoing, we'll get a step back a bit to the topic about why graphs. Why do we love graphs? I think the graphs is the most natural way of thinking and perceiving world around us. For example, bees producing honey, manufacturers producing cars, and everything is a subject, and subjects has relations between them. It's absolutely unnatural to think of world around us in tables, for example. I don't know if a lot of people wouldn't be so happy to hear that, but I think the graph is the most natural way to think about stuff around. In era of where product requirements change really quickly, I would say every week, and data sources multiply daily, relational databases become innovation bottlenecks. Every new data relationship requires schema changes, migrations, careful planning, killing their rapid iteration and modern teams. I think the other popular approach, like document databases, solve the schema rigidity problem, but create new ones. Weak consistency models, limited query capabilities across collections, and the constant choice between embedding data, risking bloating all the storage, or referencing to lose performance. I think in evolving AI and vibe coding, nothing to shy about, world, we need a simple, powerful, and reliable data engine that serves multiple purposes for multidisciplinary teams and solo builders in rush mode. And I think that's a great moment to dive into some examples.
Is that the ideology part of why you named RushDB?
I think there are two main reasons. Because I truly believe that high-performing teams are always in rush. Because if you have nothing to do in your backlog, probably your company is dead.
Good point.
That's a rough truth. And the other point, and the other reason, because we named RushDB, because the domain name was free, and we took it. That's it.
Nice.
I think, yeah. So, RushDB, let me start this screen. Quick announce what we're building today. Today we're going to build property graph out of nested data. It's a pain point for many developers when you have to normalize, denormalize data just to make fancy buttons on front end and do this stuff again backward to make sense of what users do and what they expect. Then we'll go for full featured search for books catalog and more. And I think we'll have time to sneak peek a simple rag template without headache. As I mentioned before, canonical development flow in most tech companies consists of like backend part, front-end part, migrations, deployment, data team creation, samples, blah, blah, blah. I think what we're actually doing as developers is just, sorry for simplification, but we're just making JSON in and out. I think, of course, we have to deal with the queues, we have to deal with async code, we have to deal with more and more complex concepts. But the whole process is just to make sense of data, to make data usable by databases and back usable by humans. And this is an ever-ending process that I think could be simplified. Can we say that graph is a silver bullet? I think no. It depends. You have to trade schema rigidity for relationship complexity. You have to think about how do you perceive this particular part of the world, part of the application, part of the reality that should be fitted in subjects and relations, nodes and edges, relationships and records, speaking RushDB names. And graphs, especially for seasoned developers, has some steep learning curve. Tooling ecosystem is still mature, and this is what we're about. So RushDB core components consist of five core principles for 5 components. First, it's smart data ingestion that built with a BFS algorithm that takes data on input, maps relationships and data types on the fly, and even for created complex JSON data, it takes every layer and every piece on this layer as a single node and interconnects nested nodes to each other. Next, we go for search engine. We started with speaking about platform for collectors. So the search engine is heart of RushDB. It's what we called Fractal API, or what we called self-aware database. We'll speak about this a bit later. Then a powerful dashboard for visual data exploration, collaborative workflows. We'll go there shortly. Self-aware fractal architecture that sounds really complex but makes everything simple to work with, and SDKs for popular Python and TypeScript, plus REST API for other platforms. So how we did this? We have a solid graph foundation. We have Neo4j, a backbone, Epoch, and graph data science. We love it. So let's get back to what we're building today. Sorry, the lack of points here. Yes, actually, we're gonna build this. So let's start simple. Let's go for Aura. We have an instance here. I have an instance here. It's already running. So I'll go for RushDB dashboard. Here's the homepage of RushDB dashboard. Here you have users, here you have projects, settings, subscription, and many more stuff to come a bit later. Let's create a project, and we'll name it example data with external database. It's worth mentioning that lately we delivered our new feature that allows you to use RushDB with your own self-hosted or Aura-hosted instance of RushDB of Neo4j. So if that makes sense. Sorry, I'd go for, I'm not sure. Yes, here. Here's my credentials. Please don't use it in production or to scam anybody. I really beg you. So yes, this is the password, and Let's go for it. Let's create a project. So we created a project, and now we have a token that already produced and ready to use. We have initialization script for TypeScript and Python. You can install it from pip or npm. And simple example of how to use data and API. Currently, we don't have any data here. So let's start with creating data, and let's write something. Let's name it podcast. Let's name it podcast. Let's name it title. RushDB. Now,
Artemiy, are you able to zoom in a little bit?
Yes, sure.
Thank you.
Is it visible now?
Better. Still a little small, but yeah, definitely better than before.
Let's try more, like this. Time, let's say 1. And comma here. So let's try to import this data. It's pretty simple JSON that will be ingested in our records. I'll update data. And yes, we have it here. If we go to Aura, we can see, I'm not so used to Aura user. Yes, pardon for this. Yeah, let's go for this query. What we see here? We see here our node, our relationships between properties, and what RushDB do behind the scenes is actually exposing properties out of internal storage mechanisms from Neo4j to external usage. This helps us to build faceted search. This helps us to make really quick searches on big amount of data, on large data sets. And here what we have in our data. So we have time, we have title, and this is what properties was created. This properties was ingested very simple. Let's make it a bit complex. Let's delete it. Let's go for test dataset. And now we have a large dataset. Sorry, it's AI generated. It's absolutely mess here in descriptions, names, and everything else. But the most important thing here is that it's nested. So on the top level, we're ingesting a company. This is what we put here as label. Next, we have a department. It's an array of departments. Then we have projects. Each project has employee, and employee is also an array. And task, of course. Every project has tasks. As we mentioned before, if you have nothing to do in your backlog, your company is dead. So of course you have to have some tasks. Few more toggles here. Don't think much about this. I'll discuss it further, or you can find more information about this in our documentation. But here's what's going to happen here. Let's import this whole dataset. It would take a bit. There are almost 4K of records, separately levels, as I mentioned, BFS algorithm. Let's update the page. I'm not sure how to do it automatically. And yes, we have everything we looked for. Interesting part that if we go here for example, for a task, we can see task source, task own properties. We can see relations. We have a default relation here from project. It's incoming relation because in original data it was nested. What we have more here, as you remember, we discussed faceted search for properties and how to make Notion but for data. I was obsessed with this idea, I would say, like 5 years, how to achieve this, how to make it possible, why marketplaces are so weird. The answer is super easy, because it's hard to achieve, it's hard to do, but I think I can admit we kind of succeed in this. But we'll go for this a little bit further. After creating records, let's go back to projects. Pardon. So yeah, here we have that we are connected to external Neo4j. Let's create new project and name it books. Won't connect Neo4j at this time. We'll run on internal Neo4j instance hosted by RushDB. We'll copy this token and go finally coding. Let me see, where is my ID? Oh my God. Yes. So what we have here? Here we have a simple import data script with, pardon, not yet, with this dataset. It's really great because it has different fields. It has numeric values. It has a large text. It has like thumbnails, categories, and everything what we used to do when we work with real data. So let's get back to coding, and the code would be pretty simple. We're importing RushDB, and we are defining database RushDB. We're putting here our token. Well, opening data, this data we've discussed lately, is around like 7K of books. Great collection, by the way. And we'll open this book and we'll import this data to Neo4j using RushDB API. Let's go for it. We'll need console, and it would take a bit time, but I'm pretty sure that everything goes smooth. Every time I'm telling like this, everything goes not so smooth, but I think, yes, cool. Let's get back to our stream and update the page. And here we go. We have our books here, around 7K, as I mentioned. Let's try to make some search. Let's look for Bradbury. Great writer, by the way. So looking for Ray Bradbury. And let's look for the books with the rating more than 4. Oops. Let's try again. It's still weird here. Yes. I see. 4 and 14 is bigger than 4 and 1. It's ChatGPT generated. I'm just joking, not like that, but we'll definitely look into it. So here we have a book. Let's try to make it even more fancy. As I remember, as we discussed, goal of RushDB is to provide simple way of building graph-powered software without frictions, without steep learning curve, without dealing with migrations, without dealing with data ingestion. So the main idea is pretty simple. You import data, you get it automatically normalized, and then you have to build software around it. And we do this, I think, every day, every week, and we've got something. Here we have our demo application built on top of RushDB. It's absolutely vibe coded, to be honest. This front end written just in like few hours. The backend part is not exist at all. But if we go for token here, let's put it here. And what we see books that we're just ingested in our dataset. Let's go for authors and search for, let's say, Agatha Christie. Yes, we have few books, I think 37 of them. As I mentioned, we have a faceted search for options that and filters that become more and more clever as much you search. So for title, we'll have only values that available only in this subset of data. If that makes sense, when you're looking for some PlayStation produced by Sony on marketplaces, you won't find, if you pick some PlayStation or Sony vendor in filters, you probably don't expect to see Steam Deck or Xbox. This is how it worked, and this is how it made by big teams, huge companies, marketplaces. Now imagine that the same experience can be built out of the box by only one front-end developer. This is what we for. So if we go for, no, it would be really boring to dig into API, but we have here API logs, and we can see what we're actually doing here. And this is what we call self-aware database. While we searching for records, we can also search for properties, which I showed you here. While we're searching for properties, we can filter properties by matching records by specific criteria. If that makes sense, I'm looking for properties available amongst records that contains these particular values. For example, for categories, I'll have here only detective and mystery stories. Let's make it more interesting. Let's go for categories. And yes, now we have more of them. So let's get back to the code. I'll show it really quick. These filters and this code, as I said, there is nothing to do with backend logic completely. So if you do some internal tools, dashboards, CMS platforms, or web platforms, SaaS tools, you probably do something like that. You take data, normalize it, denormalize it, create controllers, map data to controllers back to front end, receive the data, denormalize it for its needs, and then making fancy buttons, cards, and forms, and whatever you need. RushDB helps you to skip this routine completely. So here we have database instance. It's simple imported from JavaScript SDK. And if we see how database is used, let's go for, here. we're looking for properties. We're looking for property values. It's just a front-end code. No backend ever existed. No controllers, no servers, no services. Of course, you have to deal with guards, access, and you have to hide from front-end token. But the main idea here is that you can still build full-featured front ends, full-featured applications, and make graph thinking available for broader audiences and accessible even for really junior developers to build this stuff. I would say that, and I think that it could sound really immature or naive, but lately I was co-founding educational startup that was for mining industry. I mean, real mining with the big, huge trucks, with drilling rigs, blue collar workers, and all the stuff. And the idea was to address the knowledge gap amongst blue collar workers through interactive learning. What we've built there, you'll see this platform was built only by 2 front-end developers. Only 2 front-end developers do all the stuff, analytical processing, all the stuff behind. So the idea is simple. Blue-collar workers get their assessments online in browser, working with machines, picking some options, making some decisions on what should be done. Then data collected to RushDB, and then using power of aggregates, we'll speak about this shortly, we can create experiences. We can create experiences like this. So some students already completed the assessment, and now we want to see some analytics about how did they pass the exams, how did they pass the thing that they worked on. And here what we have. All you see here wasn't vibe coded, honestly, because those days vibe coding never existed, unfortunately. But all the stuff here, all analytical processing, all collecting, all aggregations, and whole the platform, users, telemetry from 3D scenes. I'll show you how it works. Actually, I have links here. All the stuff built completely on RushDB without huge backend stuff that usually use. Not pardon for this. Yes. So students are working with models, looking for some elements, clicking on some interactive elements, triggers. We build some stuff around this. We build some telemetry that counts how students perform, and this count go to RushDB, then go to front end, and all, I'll repeat it again, I'm really proud about this, all the stuff built completely by only 2 front-end developers using RushDB. So I was mentioning before that we have aggregations. Let's go for it, and I'll discuss how it works naturally. Before we go, let's discuss why. So quick recap, how it works. We use JSON to Neo4j graph. We have company, department, structure, and all the stuff created like that. RushDB underlying topology isn't so hard. It's basically, I would say, property graph. So if you have a car and if you have a house, you like one. If a car red and share color white, for example, they share common property name and type color of type string, they would be both searchable from single node. Imagine like you're doing search not by selecting single table and then making junctions, making joins, left joins, inner joins, whatever. It's like having ultra power to search amongst whole data set by properties, not by type of records, not by type of labels and other stuff. About supported data types, we support strings, numbers, date times, booleans, and nulls. And before we go to our cool super pooper feature with aggregations, let's look a bit why we love Cypher. Cypher is really appealing, self-explanatory, and visually really understandable, even for people who never been writing queries on any query languages. So we're looking for Alice's friends who like pizza. We look for Alice. We look for her friends, or his, if we're talking about Alice Cooper, for example. We're looking for likes, and we're looking for pizza. Pretty simple, straightforward. And now look why some people struggle with SQL. I love both of them, but I think this one, Cypher is much more easier to think because it's, as I mentioned before, natural way of thinking about world around us. So yeah, this meme time. So let's get back to our data store, and let's look on this. As we see here, we have the same representation of data in this vibe-coded app, and the same representation of data here. This is the actual data set. Let's go for this secret button. It's actually not secret, but it's quite small. Maybe we should do it bigger. So what we have here, we have an interactive playground that allows us to build queries using RushDB specific language. But RushDB language, RushDB querying language, is an abstraction that inspired by MongoDB and inspired by JSON itself. So if we push JSON to data store, if we use JSON, if LLMs use JSON to communicate, why don't we want to ask for data using JSON? This was a quite near idea of GraphQL. Anyone remember GraphQL? Nobody claps. But yes, GraphQL is great technology. It has some benefits. It has some pros and cons, but you have to deal with the complex concepts in GraphQL, like server resolvers. If you ever build GraphQL server by yourself, I think you'll be itching now, because it's quite complex and could be a really mess. What can RushDB do without it, but having GraphQL and MongoDB language as an inspiration base? We'll see shortly. So currently, we're not looking for something specific. We're looking for just all data we have. Let's go for it. We see all the data we have. Now, of course, our today delivered feature, I personally worked on it. Let's go for it again. So here we have a query, and here we have actual Cypher representation. It's really useful if you still prefer go to query interface or make some manual work on tweaks and performance tweaks and dealing with some complex stuff. It's really helpful to get inspire yourself here. Now let's go for basic query. We're looking for employee where name starts with Sam and salary is quite big and good for Sam or Sam's. As you see, we're ordering by ascending order. This means that we'll order records in the way they were created. How do we understand what record what record was created earlier and what later? Behind the scenes, RushDB use UUID version 7 that represents timestamp but encoded. So it helps you to use it in lexicographical, I'm not sure how to pronounce it correctly. I think you can understand it. You can use it in lexicographical sorting order. And as you see here, we're using record RushDB internal RushDB key to use it in this sorting order. Let's go for this. And now we have more complex query. We're using where and records with name that starts with Sam. Also, we use and to find the same record matching some particular condition for a salary. That was pretty easy. Now we have not so much people here, but Samuels or Sams are pretty good workers, I think. Let's go for advanced search. Now we're looking for, as you remember, I said that if we push JSON, why don't we ask data back with JSON? We have our labels here. We have task, employee, company, department, and project. So we're looking for department with name contains E. We're looking for department that connected to project. As you remember, every graph or every graph traversal is kind of finite path that could be expressed in JSON. So if finite path expressed in JSON, we can use JSON to search using this architecture. So we're looking for, once again, we're looking for department with particular criteria. We're looking for project, budget. We use here logical grouping. We use for either logical grouping excluding or, and we're looking for project. We're going deeper and deeper of our data set with employees with particular salary bigger than some particular amount. Let's go for this. And yes, our Cypher query become more and more complex, but our mental model is still constrained or freed, depends on what side are you, by JSON thinking and structured thinking about data nature. So we have basic and advanced query. Let's go for finally aggregations. Sometimes when you build front ends, and if you build front ends like this with analytics, and you have to calculate some particular information, collecting it from nested records. For example, if you build some kind of a bookstore with users, you probably want to show user dashboard where user will see how much books do he have, how much friends he have. So everything like that. If you're building some financial dashboard, you want to calculate salaries to, navigate and steer your company in the right direction, maybe hire more people, maybe unfortunately process some layoffs. This is what you usually do with your data. Let's go for simple aggregations. So we'll go to find a department with project, and we're going to find the projects collected names. It could be still quite tricky to understand, but Let's run it and see what happened. Now we have departments. So on top level, keep in mind that we're speaking normally, not like Yoda. On top level, we're looking for department nodes. And this is what we have. We have departments and the first citizen item in our results. We're looking for department name. As you remember, I mentioned GraphQL, you can rename resulting field with the actual name. So while department has name, you can return it in department name. Your front-end developers would be happy that they don't need to, figure out where the API documentation exists, because they don't need it. They can just build their own query and you can process it safely and everything would be smooth. So next we're going to collect projects, and as we see here, we have project names. Let's go for more complex example. We'll look for project. Our first level record would be project. We're looking for budget at particular amount, and we're looking for employees. So we're looking for project connected to some particular employees. Alias here, it's like a variable that will be referencing later in our query. So let's do some math about how our employees doing. Are they happy? So we're looking for their count, we're looking for their total wage, average salary, minimum salary, and max salary. Thank you for Neo4j functions. Behind the scenes, they used to do all the stuff on this. Let's run it. And we have something that could be already used without any backend efforts by your front-end team to build a dashboard. Plus, this could be extended with a self-aware approach where filters that could be applied. Imagine you're building something like superset, but you have nothing to do with backend stuff ever to make widgets, dashboards, and everything else, because your filters becoming smarter as much you filter, and your data adapts rapidly and real time in a way that we're used to. So here we have our project with some stats. Let's go for this fancy button. Now you can just copy this code and use it in your applications just to access your Neo4j data. If you go for deep aggregation, so you're looking for company, department, project, employee, and we're looking for date of birth of particular year. I'm sorry, I'm still sharing. Yeah, everyone here? And yes, everyone live. Cool. I hope you're not sleeping. So if we go here, we see that we able, using only aggregations, to construct our data in original shape that we ingested it. Imagine that you don't have to spend a single minute of thinking, how should I normalize this data set? Because you can save it as is and you can receive it precisely by levels from different ways, because you can traverse graph from different paths. So the complex example becomes really complex in Cypher, but still looks like a plain JSON here, plus some stuff like operators and other things. And the last but not least example here, you can play around it. We're looking for nested aggregation. I'm not sure, is the same one? Yes, probably looking for department with alias, with project, with employee. So we're constructing our data in a previous position. And the previous example, was about traversing through company to department to project to employee just to collect employees with a top level record company. So that's pretty much of what we have currently in our dashboard. We have a limited time, actually, I see. And last fancy stuff, we're actually working on it. It's a graph representation in 3D. We're going to add more tools here because as we work with the natural property graph, it would be really beneficial to explore your data from property perspective. For example, if you load some transactions data from bank or from financial institute, and using graph perspective from properties, you would be definitely easy to find some fraud networks or something like that, because this graph naturally increases amount and size of the tape we have here as much relations holds, if that makes sense. So stay tuned. We're going to make even more fancy stuff here. Unfortunately, we don't have time to speak up about models, but I'll try to be really quick. Do you see my code still?
Yep.
So we have models here. We are really like TypeScript. Me personally, really into typing theory and all related stuff. So what front-end developers are obsessed with is about making stuff without errors. Yes, that's a joke. And here what we have. We can dynamically define model, if you still like models, using RushDB JavaScript SDK. And this approach allows you to create records of particular type and make it type safety in your code. So still your Node.js and front-end developers, UI engineers would be really happy, because what we can create here is, let's create a new post. Yes. We created new post. Post consists of a lot of fields like title. I'll move it a bit further here. And the type inferred dynamically based on model definition. So what we have here is post is quite messy to work with. Let's go for author. It's pretty simple. Let's create author. Create author. And let's say the name would be Artemiy. Why Sidorov? I don't know. Okay, let's be Sidorov. As you see, we have name and it's required. But if we put some unexisted property, there would be an error. It's really easy to understand how it works, and it really helps development, especially JavaScript, TypeScript development, to control consistency, data integrity, and all this fancy stuff we're all obsessed about. So I think this was pretty intensive, and probably at some point it was boring and too tech-cheap, but anyway, thank you for your time. And yes, these slides we won't use it anymore, and this is our main idea. So why we don't use JSON for the best? Let's recap it again. And that's it. Thank you.
Thank you, Artemiy. That was amazing. That was really fantastic, especially using JSON as a way to search, right? Almost as a GraphQL alternative. The aggregations feature that you've added, yeah, super. So I haven't used that before. So I've only used ingestion processes for RushDB, which is already fantastic. So I had a few questions that kind of popped up as you were talking. First one is when you mentioned vibe coding that demo. Well, which platform are you using for vibe coding? Which one would you recommend for folks?
I'm using multiple of them, but I'm really into GitHub Copilot because switching between local running models like Llama or Quen, or switching for most popular like ChatGPT or Anthropic ones, it's really smooth. So I'm really into Copilot.
Nice, cool. And for the search, when you were showing it off, it looked like the search feature required kind of explicitly targeting certain property values or strings. Is there an option to do searches by kind of like fuzzy matching for values in from given properties?
Actually, unfortunately, we have only 5 minutes. We already integrated support of vector data.
Ah, okay.
I didn't mention that. We have to polish it, but it's already working for some demos, and we have example in our repository. You can explore it. So we support vector. As we support vector, we can build rack. If we can build rack, we can run embedding models, and we can not performing fuzzy search, but performing semantic search, which makes it even more fancy and modern. I think in a way of ingesting.
No, that's great.
Data random, looking for some RAG software solutions.
Nice.
Like that.
And that's a great lead into my kind of closing question is, what's on your roadmap or what's on your vision for the future for Rush?
Thank you for asking. We have a lot of stuff to do. Of course, we are aiming for wider distribution by producing more learning materials, by producing more guides to work on our documentation. It's already pretty nice, but we have a lot of things to do there. Also, we're looking for MCP server. It would be pretty easy to do because now we have good documentation and typings for everything. So I think it will be finally to kill outdated, tables doing table stuff mindset and replace with dynamic, adaptive, self-aware data. We're looking for M88. I'm not sure I'm pronouncing it correctly, but I'm pretty sure you get M88 product, workflows. Yes, this one, integration. So devs and non-devs can create powerful automations with RushDB as memory and self-aware query logic, and React for instantly changes to make some analytical workflows even more smarter. The next one, we're looking for building real-time queries, real-time subscriptions to make it really easy to replace Supabase or Strapi, to power hybrid apps. No pipelines. So imagine you're building a platform like Medium, and your UI team ships silky interface, really smooth, and the ML team builds a smart recommender. And with RushDB as a driver for this, you don't need even an NLP pipeline, because real-time query will trigger some data flow on the Python side, because new article was already published, and you don't have to manually working for some configurations for airflow and other stuff that we're used to, but not because we want. We're forced to use some technologies because they're used. So, and of course, the last but not least, we're looking for closer Aura integration, as Aura, yes. As Aura provides really cool REST API. Why don't we use it in our dashboard on project creation time? For example, if you create new project in RushDB, you can create Aura instance and start working instantly without, hustling and bustling in your browsers, switching tabs, and everything else. You can just spin up a project with a Aura instance, and you're good to go. So this is really short overview of what we're aiming for and what we are for. So yes, welcome to our GitHub, LinkedIn, website.
Cool, awesome. Yeah, we'll definitely post links for people to follow you. Okay, cool, awesome. Thank you, everyone. Yeah, we're right at the hour here. I'm just going to close up with letting everyone know about some upcoming events in the next live cast here. So let me share this with you.
Thank you.
All right, so the next stream will be on 24th of June. It'll be on Cypher, verifying Cypher queries with Christina Maria and Iona. And after that, we've got a couple things going on this month. So this is certification month. We're focusing on Graph Academy. So if you haven't already checked out Graph Academy, it's our free online learning course. Check it out. There's lots of great courses. Adam and Martin are constantly producing new courses as well. And just a couple days from now, June 10th, Adam will be doing an AMA, Ask Him Anything session. So definitely join that. And then a whole lot of events for the rest of the month here. Also, we've got Nodes 25, which is our online developer conference, which is happening towards the end of the year, November 6th this year. And we are still taking submissions for sessions. So if you've got a great graph idea or some lessons that you've learned in dealing with knowledge graphs or graph-related technologies, definitely submit a talk. Artemiy, I'm looking at you for submitting a talk as well.
Already submitted.
Okay, love it. Awesome. Cool. All right. So if you're looking for more information on Neo4j and Aura, definitely, again, check out Graph Academy and check out our website. And you can scan this QR code if you want kind of to quickly jump into our developer pages. Again, thank you, everyone, for joining us today. Close this up. Yes, thank you again for joining us. And Artemiy, thank you for your time. This was really great. I'm super impressed with what you've built with RushDB. And yeah, I'm looking forward to new developments and new iterations and new features coming out so that I also can use it for demos and other projects.
Thank you. Thank you so much.
Yeah, you're welcome. All right, everyone. Thank you so much. Thanks for joining. We'll see you in the next one. Goodbye.